Chapter 3, problem number 51. Two passenger trains are passing each other on adjacent tracks. Train A is moving east with a speed of 13 meters per second, and train B is traveling west with a speed of 28 meters per second. Part A, what is the velocity of train A as seen by the passengers in train B? And part B, what is the velocity of train B as seen by the passengers in train A? So let's start out. Train A is moving east with a speed of 13 meters per second. So this is the velocity of train A relative to the tracks is 13 meters per second east. So I'm going to call east positive. Okay, so think of it as positive when I put it into the equation. Then we have the other train traveling at 28 meters per second on an adjacent track west. So that's train B. In part A, the unknown is the velocity of train A as seen by the passengers in train B. So we're looking at the velocity of train A relative to train B, because the passengers are in train B and they're measuring the velocity of train A relative to them. So the unknown is VAB. So we're going to take VAB, add it to VBT. Notice that this subscript and this subscript are on the inner part here, so they're right next to each other. That's what you want to do. That's equal to VAT. So solving for VAB, we get VAT minus VBT. Or in other words, 13 meters per second east, that's positive, minus VBT, 28 meters per second west, so that's negative. So we really have 13 meters per second plus 28 meters per second, which is equal to 41 meters per second. Part B, what is the velocity of train B as seen by the passengers in train A? In part B, it's asking what is the velocity of train B relative to the passengers in train A. So it's very similar to this, except we're going to write VBA now. So now we solve, since we found VAB, well, VBA would just be the negative of VAB. So VBA is equal to the negative of VAB. So we just have negative 41 meters per second, or in other words, 41 meters per second, and that would be west.